Video này do mình, Cương bên NpsLab.vn, tự chỉnh sửa phụ đề hoặc lồng tiếng bằng công cụ, thấy vậy thôi, chứ tốn công lắm á. Thấy hay thì nhớ bấm theo dõi kênh, cho mình thêm động lực làm mấy video phòng lab xịn sò nữa nha.
You go to load a gel, here are some tips to do it well. The base thing is really to practice, but here are some tips to help starting with tips. So gel loading tips are super duper helpful. They're long and skinny as opposed to short and fat. This is going to let you go into the very bottom of the well, which is really important, especially if you're running like a continuous gel, something without a stacking gel. The stacking gel, the purpose of the stacking gel is it kind of gets everything to the start at the same time. So you imagine when you're pipetting in, especially if you have a large volume, you're going to have like a column of sample, and what's on the top is going to have like what's in the beginning is going to have a head start to what's on the top. The stacking gel, it has bigger holes, and so everything gets concentrated down through in that stacking gel, so they all get to the actual like resolving gel at the same time. This is going to help you, even if your sample was kind of like up in the wells, if you didn't load too well, it's all going to start at the same time. What happens in one of these other gels is that where you load things, it's going to start. So if you're loading and you have like a big smeary column, then you're going to have a big smeary band in your gel instead of a nice fine crisp line. So what you want to do is get into the very bottom of the well and then pipette slowly. So I was running one of these Urea-PAGE gels, which is you can use to separate like small bits of RNA and DNA. The urea helps like erase the size, just like with SDS-PAGE, you have the SDS erase the size. Pretty cool. I'll do more on that in the future. But anyway, it's really important there because you don't have this continuous stuff. But here are some tips that'll help you no matter what type of page you're running. The first is to like find the well. So this can be kind of hard. What you might want to need to do is actually just like pipette up and down some liquid. Once you find the first well and you pipette something in there, then it's easier to find the rest of them because you're evenly spaced these wells. Some of the precast ones have the wells like drawn on there or written on there. You can also put a marker on there, but make sure like write on it, but make sure that you're not gonna then wash it off when you're doing it. So make sure it's like a marker that's like a lab marker. You can also sometimes like stick a sheet of paper or something behind it to help kind of be able to see the outlines. And so when you're pipetting up, so depends what your strategy is. Are you trying to pipette like all your sample in? Like maybe if you're doing a purification where you're actually going to extract things out of your gel, then it's really important that you get all of your sample. Whereas if you are just wanting to visualize it, then you just need say like a set amount, and maybe it's really important that you get the same set amount for each of them. And then you want to make sure that you make extra sample. So typically make like 1.5 samples worth, or if you're worried that you might have to run it again, make like 2.5, that sort of thing, so you have backup. So if you are just doing a set amount, this is less of an issue. But if you're doing something where you're trying to suck it all up, you want to make sure that when your pipette is set to like whatever a larger volume than you're actually going to load. But when you go, you don't want to introduce a bunch of air bubbles. So instead of doing like that, now what's going to happen is when you go to pipette it in, you're going to get an air bubble, and then your sample is going to hit the air bubble, and your sample is going to like be all smeared and squishy and blind, or it's going to like pop up out of the well because the bubble is going to burst, and then it's going to pop out of the well and then get into all the other wells. Not good. So what we're going to do is pipette up till it's just the tip. And now you can load it like this. So you want to make sure that you're not pressing down before you get into the gel well. Then when you get into the gel well, you want to go all the way to the bottom and slowly release. You can kind of like go back and forth along the gel line, slowly going up. And then when you go to the bottom, like what I like to do is just kind of like go to that second stop, that hard point. And then, but don't push all the way, because then you're going to get a bubble. Instead, just kind of keep your finger pressed down, so you don't want to pull up, because then you're going to pull your sample back up into the pipette, and then it's going to get all diluted, and you're going to have all these problems if you try to pipette it back in. So instead, you just want to hold your pressure there and pull gently out. So when you're doing this too, you want to make sure that if you have like a large volume or whatever, you're not just like sticking your pipette super deep in there, because then you're going to get sample on the outside of the pipette. What's going to happen is you go to pipette it in, it's going to get, the buffer in the gel is going to take that stuff that was on the outside of the tube, and now it's going to be in all of your leaves, which you don't want. So So you want to make sure that your tip is just in the very surface when you're pulling it up, but make sure it's deep enough that you're not getting bubbles, because as we talked about, the bubbles are going to cause problems.
Also, forgot to mention, so it can help to keep your elbow on the table to keep yourself steady, and you can use like one hand to steady your other arm when you're pipetting, to keep that cool, steady flow.
That's the basics of pipetting samples into the wells, so what's more important, as I said, with these continuous gels, a couple other things about, like, if you're running a Urea-PAGE gel, especially because the urea in the gel, what's going to be denaturing it, unfolding the things. It can kind of like leak out of the gel, kind of. Well, what happens is that if you can see that if you run the gel, it'll be like this layer of this like kind of more viscous stuff at the bottom of the wells, and like the urea is kind of like leaching out of the gels. You want to remove all of that before you actually run your gel, because it's going to get in the way of the sample loading properly. And so what you can do is you can take a syringe, or you can take a pipette tip and actually go up and down in each of the wells. Unfortunately, what happens is sometimes you get, like, especially if you're using a homemade gel, you can get like pieces of the gel just kind of like fly up out of the one well and into the next neighboring well. So what's really important, what you can do is you can actually do that to each well, like right before you load it. But you want to make sure you're not then like messing up the other wells, so that you can like pull it out with the more carefully than if you were just doing your up down with your syringe, because you don't want to be, basically once something's in there, you don't want to be spreading out of the cells. And also you want to make sure that you're working quickly, because the gel, the bands are going to start to like diffuse, and they can diffuse out of the well. And even if they don't go all the way out of the well, you're still getting it rising up of the column, as opposed to being a nice crisp band. So working quickly is important. In addition to the tracking die, the sample loading buffer also has something heavy. So something like some sugar, like a phycol or glycerol or something, often to give it like a little weight, so it's not just floating right up out of the wells. Some sample buffers also have other things, like the SDS or formamide for like an RNA gel. But sometimes the weighty part is more heavy than others, and so for the RNA gel loading die type, they tend to be more floaty, less weighted, whereas the ones that really have like glycerol and stuff tend to sink better. To avoid getting them out of the wells, you want to make sure you're not overflowing the wells. So the less volume you can add, the crisper your bands will potentially be with these continuous gels.
So it's less important with like an SDS-PAGE gel, but when you're running one of these Urea-PAGE gels, it's like a TBE PAGE gel or whatever, it's important that you have something in all the lanes, preferably the same amount. And so if you don't have enough samples, then you can add in those empty lanes, you put the running buffer, so like the sample loading die. So typically that die is like 2x or something, so you could just take some of your tris buffer or whatever, make a 1x, and then load the same amount of that as you loading the amount of your samples. This will help keep the current and everything constant throughout, and constant across the line, because you already have enough problems with things like your gel smiling. It can happen due to uneven heating. So things like pre-running the gel can help with that too, and not running it too hot. But basically, you want to make sure that you have the sample in all the lanes, even if you don't actually use those lanes, with like your real sample. So what you want to do is, especially because of that smiling effect, where the things in the center are going to run lower typically, like than the things on the edge, this makes it really inconvenient, especially if you have like all the lanes filled and then your ladders are on the end, and then you don't know where the ladder corresponds to your sample. So if possible, it's always good to put a ladder in the middle too, if you have enough lanes. And if you have enough lanes where you have extra, put your samples in the middle. And then put your blanks on the edges, instead of doing like samples starting at 1, 2, 3, 4, 5 or whatever, and then just have a bunch of blanks, because now your sample's going to be all weird. So yeah, typically I put like a ladder on either side, a ladder in the middle if you can, and then when I don't have enough samples, I put this, or don't have like enough samples to fill all the wells, I put the samples in the center because of that smiling effect. But I typically start putting the samples in, so I count how many lanes ahead. So ahead of time, I calculate out like, okay, how many lanes do I need to get to this point or whatever. Which lane do I need to start on with my actual samples or with my ladder. And then I put those first, and I go back at the end and I put in the blanks, because this way, if you mess up loading one of the wells, now you still have those empty lanes that you can use. Whereas if you put the buffer in them beforehand, now you're out of luck because you already have sample in there. So that's just something that you might learn the hard way, and so I'm hoping that this will help somebody not learn the hard way on that.
If you're running an SDS-PAGE gel and your sample has potassium in it, so potassium is going to precipitate with the didecyl sulfate, so sodium didecyl sulfate, the SDS, is soluble. The potassium didecyl sulfate, KDS, is not, and so then it'll precipitate out. So you want to heat that up right before you actually run your sample.
Also, be sure that your sample is not like too concentrated, or you're not loading too much of it. So this can be a problem if you are doing, say, like a cell lysate. You want to see like, oh, is it in the pellet? Is it in this fraction or whatever? Make sure you dilute that down first. You might need to do like a range of dilutions to see what's a good concentration. Or you can do like a Bradford or some sort of protein concentration thing to make sure that you're loading like a normal-ish amount. If you load too much, what's going to happen is you're going to like, everything's going to contract, and it's going to go, and you're going to get this weird smear down your gel, and then everything around it is going to like, yeah, so that's not good.
Or load your sample, and you might see like some like precipitation form, but it'll be less bad if you do the heat it up right first. Well, I think that's it. Yeah, so just basically make sure that you don't have any bubbles when you're pipetting up, that you keep your finger pressure down when you go all the way in, but you're not pushing out, just nice and firm. Then you want to push down, pull up, keep your thumb there, pull out, and voila.